Find the Laplace transform of sin raised to power 5t. Now there is no direct formula for this power. We have a formula for sin at. So our goal will be to reduce this to that particular form so that we can directly use the formula. For that, you know that sine of theta is e power iota theta minus e power minus iota theta divided by 2 iota. Okay. So we can similarly write this for sin t also. This will be e power it minus e power minus iota t divided by 2 iota. Okay. Now taking power 5 both sides. So you will get sin t power 5 equals to e power it minus e power minus it divided by 2 iota. Sometimes I say this as I. So please take that into concern. Now this is power 5. Now I will simplify this. Keep simplifying this and please make sure that we are finding Laplace of sin raised to power 5. Let this be called as ft for some time. Okay. Now I am taking this out. So 1 upon 2 iota power 5 and inside I have e power it minus e power minus it whole raised to power 5. Okay. Now I will use the binomial expansion. Let's write this as 32 iota power 5. Now 5c0. Okay. First term power r e power it power r n minus r, so 5 minus 0, and the second term which is minus of e power minus it, that raised to power bottom index which is 0. Okay, so this was the first term, plus 5c1 first term e power it raised to power this minus this which is 4, second term which is minus e power minus it, that raised to power bottom index, plus 5c2 e power it raised to power difference. Now minus of e power minus it raised to power 2. Okay, bottom index. 5c1 e power it raised to power 4 and minus of e power minus it raised to power bottom index. And finally 5c0, 5c1, 5c2, we'll have 5c3 here. Extremely sorry for that. 5c3, so 5 minus 3 is 2. Okay, and you will get the bottom index 3 here, followed by 5c4 e power it raised to power difference which is 1 and minus of e power minus it raised to power bottom index which is 4. And then finally 5c5 e power it raised to power difference which is 0 and minus of e power minus it raised to power bottom index. Now this was the whole expansion. Let's simplify it further. you'll get 1 upon 32i raised to power 5. Now 5c0, nc0 is 1, so I'm not writing that. I'm simply writing e power it raised to power 5. Okay. Anything raised to power 0 is 1, so I'm not writing this also. I'm simply going to the second term now. 5c1 is 5. Now take this into consideration that nc0 is 1, nc1 is n, okay, and ncn is also 1. Okay. Now we were on the second term, so 5c1 is 5. Then now I can bring this 4 inside to e power 4 it. This minus can be bring here. Now e power multiplied by e power minus it. Fine. Now 5c2 I have to find. Let's say now this minus will be nullified. 5c2. Now 5c2 here. 5 into 4 divided by 2 into 1. This is 5c2. How I find? Move 2 steps back from 5. 5 से 2 step पीछे जाओ. Divided by, from 2 go till 1. So this is the step. So 20 divided by 2, this is 10. So I'm on the third term, I'm getting 10 multiplied by e power 3 it into e power minus 2 it. Okay, fine. Coming to this term. Now NC, there's another formula. This is just basic binomial. NCR equals to NCN minus R. So 5C3 can be written as 5C n minus R. So 5C5 minus 3. So this is 5C2. So 5C2 and 5C3 have the same value, each being equal to 10. But there will be a minus sign in this case. 10 e power 2 it into e power minus 3 it. Okay. Now 5c4, again using the same formula, 5c4 is equal to 5c1, which in turn is equal to 5. So again 5, this minus sign will be nullified, e power it into e power minus 4 it. Okay, fine. Now finally 5c5, ncn is 1. So I'm not writing this one, I'm not writing this one. Finally I'm writing a minus sign, e power minus 5 it. Now collecting the like terms. So 1 upon 32 I raised to power 5. Now here we have this 5. Here we have this 5. And this two terms looks alike. So e power 5 it from here minus e power minus 5 it from here. So this becomes our first collection. Now second collection is this two terms I'm collecting. So I'm taking minus 5 as common. Now 4 it minus it is 3 it. So e power 3 it. And it minus 4 it is minus 3 it. Okay. And since minus sign is common, so 1 minus will come. And this will be written as e power minus 3 it. Now these two terms I can take 10 common. So 3 minus 2 is simply e power it. 2 minus 3 is minus, here 1 minus because of this, and 2 minus 3 is minus it. Okay. So 1, 2, 3, 4, 5, 6. That means 3 pair. Okay. Now, what I'm doing is I'm bringing 2 iota inside. 2 iota inside. So, the moment I take 2 iota inside, I will be left with 1 upon 16 iota power 4 outside, and the 2 iota which I am taking inside, I will be distributing it to all. So this will be e power 5 iota minus e power minus 5 iota t divided by 2 iota. This is the first term, minus 5 times e power 3 iota t minus e power minus 3 iota t divided by 2 iota plus 10 times e power iota t minus e power minus iota t. This all is in power, take that into consideration, or divided by 2 iota. Now this is looking familiar with you because sin theta is e power, sin t is to be more precise is e power it minus e power minus it divided by 2 iota. So this 3 can be written further as 1 upon 16 iota raised to power 4. Now iota raised to power 4 again, what will that be equal to? Now iota square is minus 1. Now iota square the whole square will be minus 1 the whole square, which is 1. So I don't need to write iota again. I will manage that in the next step. Now this, what is this equal to? Please say, you have seen sin t is e power it minus e power minus it divided by 2i. That is equal to sin t. So when we have sin 1t, then this is the thing. When we will expand sin 5t, then this will be the thing. So sin 5t minus 5 times, this is sin 3t, this is sin t simply. This is 1 upon 16. Okay. Now sin 5t minus 5 sin 3t plus 10 sin t. Okay, fine. Now this whole thing, what was this? F of t. So I have got f of t equals to 1 upon 16, and inside the bracket I have this sin 5t minus 5 sin 3t plus 10 sin t. Fine. Now taking Laplace on both sides, what we'll get is Laplace of f of t is equals to Laplace of 1 by t is equals to 1 by 16 times Laplace of sin 5t. So Laplace of sin 5t minus 1 by 16 for the 5 by 16 times Laplace of sin 3t plus 10 by 16 times Laplace of sin t. Fine. Now we already know one formula, that Laplace of sin at is simply a divided by a square plus s square. So this is a important formula which we are going to use. I just told in the beginning that reduce this to this. So we have already done that. Now Laplace of f of t will become, now Laplace of sin 5t, what will that be equal to? This is a sin 80, so a will be here. So 1 by 16 I am taking as common. Now Laplace of sin 5t is Laplace of sin 5t will be 5 divided by 25, 5 square plus s square. Okay. Now I have already taken 1 by 16 common, so minus 5 times Laplace of sin 3t will be 3 divided by 3 square 9 plus s square. Now 10 will be here. Laplace of sin t will be 1 because sin 1 into t divided by 1 square plus s square. Okay, you can leave this particular question to this stage only. So interesting question, interesting application of trigonometry here also, and a binomial here also, and finally Laplace was the base of this particular question. That's it from my side. Thanks and have a nice day.